Okay, when we're factoring cubics, it's actually more straightforward than it may seem. Okay, if you have a look at the slide before, you would have seen that a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. Now, you don't need to memorize that because there's a little pattern that happens, or a trick. If this is positive, and this is always the opposite. The one at the end, this one here, is always positive. It doesn't matter. So if I have a cubed minus b cubed, it's going to be a minus b because these two are the same. Then this one's going to be, sorry I didn't put a bracket, plus, because the other one was minus. This one is always plus. Okay, so I'll just do that again for you, or emphasize it, go over it, whichever you prefer. So whatever the sign is in here, whatever this sign is, it's always the same as this first bracket. Always. And it's always the opposite to the next one. So same and then opposite, and this one here is always positive. So let's try and solve it. Okay, so the cubed root of x cubed is x. The cubed root of 27 is 3. So that's the first bracket, and as you can see it's positive because it is positive, which means I now have x squared minus, because it has to be the opposite sign, a times b, so 3 times x, plus, this one always is positive, and b is 3, so 3 squared is 9. Now as you can see, this has a squared term, so it's not fully factored, so you do need to keep going. So here we have p equals 9 and s equals negative 3. There are absolutely no factors of 9 that are going to result in negative 3, so you need to use a different method. This time I'm going to use completing the square. Okay, so we have x squared minus 3x. I'm going to put the plus 9 over here. Some of you will move it straight to the other side. Go for it, you can do that. I'm going to halve my b term. Okay, then I'm going to put it in the bracket. Okay, I have to subtract it, but I have to also square it. And then I am going to add the 9. Now some of you have already got this on the right, so you might be moving that to the right as well. Okay, there's slightly two different ways of doing this, and that's fine. You just do whichever you are comfortable with. Okay, now you just need to simplify and solve. So I leave my x minus 3 on 2 squared. And I need to square this, so I get minus 9 on 4. I'm going to put my 9 over 4 so I can add it. So that becomes 36 on 4, which equals 0. X minus 3 on 2 all squared. So that'll end up being negative 27 on 4. And some of you might be able to see that we're going to have a complex root here. So if we get rid of this square, we have to take the square root, the positive and the negative. The square root of 1/4 equals 1/2, so I'm going to take that out the front. Okay, then I'm going to remove the negative, okay, as an I. Bring that out the front, and I'm going to move this to the right hand side. So I end up with x equaling plus or minus half I root 27 plus 3 on 2. Now if you wanted to, because they're both over 2, you can actually write that as plus or minus I root 27 plus 3 all over 2. which also means you're more likely to see the 3 out the front and have the answer look like that. Now remember, back to a previous slide, we still had an x plus 3 out the front. So this represents 2 complex roots, but we also had x plus 3, which means x also equals -3. That is our real root.